Hello there, hello everyone. My name is Max, and I haven't done any videos for a while, and a short time ago, I browsed the internet, and I found a pretty interesting question whether you can. As we know, we can write. There are many programming languages, like the interpreted programming languages like Python or JavaScript. Well, actually JavaScript runs on a virtual machine, but it's technically interpreted by the browser, so this is totally another topic. Also like normal Java or Erlang with their own virtual machines, and we also have this low-level programming languages like Rust or C++, which are obviously compiled into the machine code. Is there anything lower than this? The answer is obviously yes, there is. As we know, there is there is a language called assembler or assembly, which was developed in, I think, 1947. So this is basically the first programming language ever, which is basically a language which is basically a small abstraction over the machine code. And the thing is, many people can't really differentiate between machine code and assembly language. But there is a difference, because assembly language are basically instructions like add, nop, move, pop, etc. And the machine language itself are just I think 4 or 8 or some kind of instructions written in hexadecimal, written as hexadecimal instructions, which are directly executed by the processor, and we can't I can't really, and I think nobody can really read them as a human. So these are just a bunch of binary numbers following each other, and yeah, so they're nearly unreadable. And the question was whether is it technically possible to write a program without any programming language directly using the opcodes, the binary, the machine language only. And the answer is actually yes, it is possible. And this is what holy shit. Doesn't matter. So I thought, well, if is it possible, yes or not, and I did some research on it, and yes, it is possible. But and this is also what we're going to be doing in this video. But there is there are obviously some limitations. And the biggest one is the operating system itself. So actually, operating system is a very nice guy. It basically makes possible to operate our computer without any concerns, without worrying to break it, etc. But the thing is, technically we could try create our own executable with all headers. Well, manually create all headers, all sections, etc. But it's way too complicated, and this is not why we're here. And this is why I did a small trick. I wrote a small program on C++, which runs on obviously on Linux, in VSL and WSL, Linux in this case. So what it does actually, what we're gonna be doing is I hard-coded the name of the file, a func.bin, and we will create this file, and this file will contain only the binary, the opcode instructions, So what we're doing here is we're reading the file, and we're reading the size of the file. We're getting the size. We're allocating. The thing is, so if we read the binary, each program has some sections like PSS section, text section, some memory regions, heap, and the two most important of all, heap and stack. And the thing is, neither heap nor stack are executable. And this is where, as I mentioned, the operating system comes in. The operating system does not allow us to execute just any code, right? So it's forbidden because of the security reasons. Otherwise, we could some hacker could inject malicious code into any software and let it be executed, etc. So the operating system does not allow us to do it, and if we try, it will instantly return the segmentation fault. So what we're doing here is we're reading the file. We're reading the file, and then we allocating the space on heap, where we store the binary content of the file. And here's where the real magic happens. As you can see, I don't use here malloc function in here. I use memory map, which is nearly a direct Linux system call. The thing is, here I'm creating a totally unique, totally custom memory region, which is actually outside of a heap. And here I set some flags for it and prod execute. So this memory region, marks as is marked as executable, and the binary code inside it can be executed directly by our CPU. And then I copy the whole bytes I read from the file to this memory region. And what I'm doing next is I'm setting the pointer. I'm creating a new function, basically, and with two input parameters, and I'm setting this function. I set it as a pointer to this region of memory, and I basically tell my program to whatever is in this region of the map of whatever is in this memory region. This is a function, so just do something with it, run it, and then return and print the result. And here we have 1 and 2, and these are basically our parameters. And we will later I will show you how we'll add them together. So then we unmap the memory region and free the whole thing. So again, this is I have to we will not compile anything, so we will compile this program once, and then we will edit the binary file, and nothing, and by directly changing the content of a binary file, we will modify this function here, which is executed or basically loader program. This is why I'll call it loader.cpp. So let's compile it. So it's compiled. So let's open the hex editor and start and create and edit the func.bin file. So the thing is, I can't remember the opcodes because there are different opcodes for basically for every other architecture, and the thing is, but with this editor I can easily remember them. And so the first thing we have to do on every by writing any function in using opcodes is well, the command pa shows me, tries to figure out the opcode hex number for this instruction, and we have to push the RBP to stack, so it's opcode number 55. And then the second thing we have to do is move move RBP or RSP. So this is the returns this opcode. So now we want to just, in this case, we will ignore the first two input parameters, the 1 and 2 in this case, and we just want to return any, as you can see, it expects digits, and we want to return any number. So and in this case the return result is stored in the rex register, and let's for example return the digit 8. It doesn't matter which input we have; it will just return the digit 8. So let's move rex and this is the opcode to move the digit 8 to the register rex, and to finish the function we have to pull the RBP back from the stack. So pop RBP, it's 5D. Yeah, it looks correct. It looks correct, and we have to return using the red. So PA red. It's this C3 opcode. So now we have to write these opcodes directly to the binary file. We already opened it, so we can do it using command WX and just list the opcode 55 and just copy it and paste it. These 3 and it should work. Yep, as we can see, it was written to the binary. Now we can exit it, and if we will not recompile the loader file, since as I've mentioned earlier, it doesn't make sense. So if we run loader, the result is 8. Nice. So if we try to change, I think it worked. Yep. Well, it should work. We will yeah. Sorry, I accidentally let's try. I tried to replace the 8 with the 7 blue, and then the 8 replaced to digits. I thought the output digit would change it. But, yeah. Sorry. Let's, for example, change to 4. This is the opcode. So run the loader, and the result is 4. So we basically modified the function without recompiling it, because again we just modified the func.bin file. So, but well, returning a constant number isn't helpful at all, is it? So let's make the function do something useful. For example, working with parameters, like adding these two numbers. So there is a rule how and in which registers parameters are saved. So in this case, these first two parameters are saved in I think in ESI and EDI, and we have to add them and store the result in the RAX register, which is our output register, which is printed in that here. So I think so. We have to first we have to move the RSI to the RAX register. Move side, which is the right opcode, and we will add RX RDI, and this is the right opcode. So instead of just writing the fixed number, we will copy the opcode. So, and this should be the right. It looks like it should work. So let's try. Oh yeah, it got them worked. So as we see, the result is 3. So we have 1 and 2 here. If we edit it and write 7 here and recompile the stuff and loader, the result is 9. So as you can see, we successfully created our own binary file, our own bare executable, and we wrote a function using without even using assembler. So we only use the opcodes, and well, as you can see, it is possible. So yeah, hopefully you enjoyed the video, and you'll like and subscribe to the video, and yeah, we'll see each other next time. Bye bye.